In this video, we will see dry run of the code. Now let's see a quick dry run of this code. Okay. So I have one L pointer that is starting from 0. I have one R pointer that is starting from 0. And I have one count that is also 0. Okay. While R is less than nums of length minus 1. So what is nums of length? So I am denoting with n. N will be here will be 2. 12 minus 1. So yes, R is at 0. Okay. N minus 1 will be 11. So yes, R is less than n minus 1. So what I will do? I will simply take one variable here. I will come to here. Okay. Last point. What is my last point? So I will say my last point is also 0. Okay. Because I am starting from here only. Okay. So I will start from here. What is L? L is 0. Okay. So L is pointing to here. R is pointing to here. Okay. What will be the last point? That is met dot max of I plus nums of I. I 0. Okay. This is standing for I 0. Nums of I is 2. 0 plus 2. Okay. So the last point can I achieve? Can I say that this is my last point? Okay. So this is the last point that I can achieve. Yes. So I will simply achieve it. And once I will do I plus plus, I will be greater than R. Okay. So I is at here. So that's the end of the for loop. Okay. My L will be R plus 1. So my L will be instead of here, it will come to here. Okay. And R will be last point. So R will be here. And the range I am getting is this one. This is my range. Okay. And I will update the count. Count will be, let's update the count here. Okay. Count will be from 0 to 1. Okay. Now again I will come to this. Is still R is less than n minus 1? Yes. Okay. My R is here is less than 11. So I will come here. Again I will, again my last point will start from 0. So either you can again update your last point or you can mention to last point here. And again you will start from L to R. So what is L? This is L. You will start from here to here and you will find out the last point. So if I do 1 plus 1, I will get 2. Okay, that is not maximum. Again, we need to find a maximum. If I did 2 plus 1, so I will get 3, right? So can I say my last point will be here? Okay, the maximum, because after this for loop, my last point will be here. Yes. So L will be R plus 1. So R is this. L will be here. R will be last point. So R will also be here. Okay. So your new update, let me remove all this. Okay. So now your new update will be your last point is here. L is here. R is here. This is the new range that you got. Okay. This was the previous range. And once you got the range, you will update the count. Count will be 2. Okay. Again, you will start from last point equals to 0. So LP suppose here again starting from 0, or you can define it here. That is also fine, I guess. Now for L to R, again, that means from here to here, L to R. Okay. What is nums I plus nums of I? So 3 plus 3, 6. Can I say that your last point will be here? The last point will be here, right? So your new range will be L equals to R plus 1. So R is this one. So L will be here and R will be last point. So R will be here. This is your new range, right? This is your new range. Yes, this is my new range and I will update the count. Count will be 3 now. Okay. Once I updated, again what I will do, I will check is R is less than n minus 1. Yes, R is at 6. It is less than 11. So I will again come to this loop and I will start from L to R. Now L and R, we have this point. Okay. Again, let me remove all these things. Now L is here, R is here. Okay. Again, I will start and I will find the last point. Okay. Last point will be maximum of I plus nums of I. So 5 plus 4, I am reaching to 9. Okay. 5 plus 1, I am reaching to 6, not a last point. 6 plus 2, I am reaching to 8, not a last point. So can I say my last point is here? Yes. Okay, the maximum last point is 5 plus 4, that is 9. So L will be R plus 1. So your L will be R plus 1, you are here. R will be your last point, so R will be here. Your new range will be this one. Your new range will be this one. Okay. So this is your new range. What you will do, you will update your count. Count will be 4. Okay. Again, your last point start with 0. Last point will start with 0. You will come here. I will be L. So again, you will start from here. Okay. Let me remove all this. You will start from this L, okay, and you will figure out the last point. So 7 plus 2, you will add 9, okay, not a last point, not a maximum. 8 plus 3, okay, you will be at 11, okay. So you will be at here, that will be your last point, maximum last point. 9 plus 1, you will let be here, not a maximum, right? So this is the last point that you have achieved. Okay, for this for loop, you will come here, L equals to R plus 1. So L will be here, okay, and R will be your last point. So R will be here, okay. So if I remove all this, okay, this will be your new range, L and R here. This will be your new range, okay. You will update the count will be 5 now, and you will check, is your range is less than 11? No, it's equal to 11. That means you reached here, right? This is equals to 11. You are at the end, okay. You will end the loop, you will return the count. What is the count is 5. So answer will be 5 here, right? So this is how you are calculating the last point, okay. This variable you can declare it here as well, right? We simply checked out, there is no change, okay. So this is how you can solve it. Basically you are calculating the number of ranges. This is one range, two range, 3, 4 and 5, okay. The total number of ranges that you are getting, that will be your answer. That minimum number of jumps, okay. That means the minimum number of jumps possible here in this range. So how that is possible, that you can either take this jump and you will take this jump, then you will take this jump, and this will give you this point 3, and 3 will give you this point, okay. So yeah, this will be your answer, okay, and this will be your dry run of the code. Let's quickly discuss the time complexity. Again, simple single while loop, okay, and inside that for loop, but this is for checkpoint, okay, not contributing in complexity. You are anytime you are running till L2R, 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 that means only n times. So the time complexity will be big O of n, and space complexity will be big O of 1. You are not taking any extra space, okay. So yeah, this will be your time and space complexity, and that's all for this problem. We'll see you in the next problem.